Welcome to Symposium on RiotRadio.ca, your friendly neighborhood automatons.
Yes. Sorry about the delay this week, folks. Hopefully we'll have it worked out next time.
So I'm your host, Roman Chodan, and I'm here with my two co-hosts, Keegan Gwendolyn.
Hello.
And Mackie Drew.
Hello there.
Let's move on to our first section, according to my research. All right, Mackie, do you want to start?
Sure. Today I've brought a little factoid about a little bird from Europe. It's called the ortolan bunting, and it's traditionally eaten, just like any other bird. But what you'd expect with a bird that's eaten is, like a big thing, like a chicken or a turkey or a
ostrich.
Something. Yes, an ostrich, exactly. Or penguins, the classic eating birds. The ortolan bunting, however, is more like your classic, average bird. The ones you see just flying around. It's just a little thing. Maximum size is 16 centimeters long, but that's from head to tail. They actually look quite small, and they only weigh about 25 grams. Wow. So
that's real small.
Yeah, so it's like legit popcorn chicken.
Exactly. Yeah, the interesting part about the ortolan, though, is it's in the way it's prepared. It's prepared by the French, and in a very
it's prepared by the French. It must be prepared by the French.
It's prepared by the French. This is a French thing, obviously. Well, you'll see. It's done a little bit cruelly, just a little bit. So basically, what they do is they catch the birds and they put them into a dark box. And for about a week, it can be shorter. I've seen as low as 1 day. They'll keep them in the dark box and they'll feed them really tiny little pieces of figs and just keep feeding them. They're basically force feeding them to fatten them up because, again, they're not very hefty. And
what is the dark box?
Yeah, the dark box is actually messes with their schedule, their sleep schedule, and they just keep eating. They can't figure out. It messes with their internal clock, and they're just going to keep eating until they blow up.
Until they're more than 25 grams.
So yeah, until they're more than 25 grams, exactly. So yeah, once they're finished with that process, which I'm sure is not so flattering for the bird, what they'll do is they'll basically just grab the bird and they'll put it in an oven. They put it in the oven dead.
Well,
or there's a few different stories about exactly, this is a very old dish, so we have a few different stories about exactly how it's prepared.
It was probably prepared differently over the years.
Yeah, so you just basically stick it in the oven for about 8 minutes and then just blast it, and then it's cooked, ready to eat. But
with the feathers on and everything?
With the feathers on, all in one. Really? Yeah, the feathers just tend to burn up a little bit, you know what I mean? But
wonderful smell.
Yep. But the figs sweeten it up. But yeah, I saw one where they actually wrap it in bacon alive. They put it in the oven, so it won't fly away. Then they
restrain him with bacon,
put it in the oven, and then they put it just for 8 minutes again, and then they take it out, and then they remove the bacon, and they don't eat the bacon part. So what they do, and that's kind of a big part of it.
It's all feathery now.
It's actually traditionally eaten to hide your shame. You put a cloth over your head when you're eating it, so you can't see what horrible thing you're doing to this adorable little bird.
There's a million better ways to do that, though.
There's a couple stories.
Can you imagine carving that tiny little thing, like a little X-Acto
knife? Squeeze it, and its breast just all the meat just pops out from skin.
Actually, you eat it whole. You eat it. You grab it by the legs or the beak. There's different stories, but either one would just break up when you eat it anyway, the beak or the legs. So you eat it in one bite with this blanket over your head. And then it's apparently
and you eat the bones and everything.
Yeah, bones break up. They're fine.
Wow.
It's a tiny little bird. It cooks like nothing, right? Turns to dust. So yeah, that's the ortolan bunting. And
do you have any stat? How much would that cost me in a restaurant?
Oh no, I don't.
Keegan's hungry.
Yeah.
I
I'm
don't.
hungry for tiny birds.
It would cost you. I can only imagine it cost you a lot because it's actually now banned. The preparation of this is banned in France, at least in the traditional way. So
Of cooking it alive.
cooking it alive. Yeah.
How do they kill it? You said sometimes
Small
they.
guillotine, like a cigarette, a cigar.
If they aren't going to do it alive, they
Yeah.
leave it into the box till it's dead.
Oh,
Okay. Anyway,
that's a little dark.
Till it's eaten all the things it can eat.
it eats itself to death. And anyway, Roman, you've got something for us too.
Yeah, I was looking up, trying to find things for this, and I looked and I thought of what the smallest, the smallest size of the smallest physical size of a byte you can have, or even like a bit. So a bit.
So what's
is,
a? Oh yeah, okay.
So this is like information. So a bit is a binary of 8 characters, right?
A bit is a 1 or a 0. It's an up or down.
Oh,
it's
just
like
so a byte would be.
It's like an up or down lever. It's on or
okay,
off.
right.
And
so
then a byte is 8
of
of those.
those. Okay. So for
And this is just like a packet of information.
Yeah, it doesn't
Yeah.
have to necessarily be about computers. It can be anything.
yeah, it's like it could be like 8 flags in a row. Some of them are red, some of them are green, and that could be a
Why
a
8?
byte.
Is there something significant to the fact that there's 8?
I guess the amount of I have no idea.
Is it just like, oh, you can have a lot of things with different combinations?
it's-
I imagine it's the way computers.
It started as a preference, and it turned into how all computers are built up on architecture.
So it was really
Entire
just
architecture.
arbitrary to start with.
Probably-
Not entirely, but it's a long story.
yeah,
so
probably
okay.
probably works best for computers, I imagine. Anyway, so IBM.
Mackie gave a skeptical eye to that.
I have no idea. I have no idea.
go on.
I have no idea. I'm not the computer scientist. So IBM came out with a hard drive that can actually store 1 byte of information on 12 atoms.
Oh, cool.
So that's pretty small, I would imagine.
Yeah.
12 atoms is small.
Yeah,
All right.
that's all I really have.
Oh. Okay.
Okay.
I guess that's the size.
How do they?
Alright.
Do they read? Can they read and write it? Do you know that?
I'm not 100% sure. It was
Okay.
I didn't really get all the details, but they showed like one of those scanning electron micrograph.
Yeah.
Oh, okay. Then
Things of it.
they definitely could then. Okay.
I just read something today, actually, that's sort of related. Scientists have encoded some famous information into DNA.
Yes, into the 1 gram of DNA. I read the same story. Yeah.
So I know they did Martin Luther King's "I Have a Dream" speech. They did
The works of Shakespeare.
Shakespeare's sonnets,
But the real
and
importance
a couple of other things.
The real
as
importance
well.
of this is what they were able to encode. I think it was 16 petabytes of information into 1 gram of DNA.
It was just an extremely large amount of information that fits into DNA, which can be stored for thousands of years if you store it properly.
we were
It's very
actually
high.
That's awesome.
we were actually very it's very interesting because we were able to do this before. The important breakthrough here is that we're able to read and write it easily and quickly. Because before we could encode it and then we'd have to sequence the genes. Basically.
So how do you read it then?
How do you
in
read-
this new way?
We have great new technology about how to sequence genomes.
So you still have to sequence it.
Yeah, you still have to
obviously.
sequence it, but it's the update is the writing.
All right.
And that's a new breakthrough. But
It's like,
I wanted to talk about that in another
It's like
week.
Craig Venter's organism that he made. He encoded like I guess it's the URL of a website for that
Yes.
organism, so that like any scientists get the Easter egg if they sequence the genome and uncover the code that's in the genome. It like has this.
We're
it
talking
has
about the fully
names.
synthetic organism.
Yes.
Craig Venter made.
It has the names of the scientists who contributed and like the URL for a website.
That's awesome. How much did he say that costed him to make?
Oh, I don't know.
He said he was holding,
Millions,
he
I'm
was
sure.
holding like
The
a
website.
plate, and he was like, "This cost."
Oh yeah,
Yeah,
that's
so
right.
it wasn't
I
like
can't.
like
I can't
$1 billion
remember.
or
It was a
something?
lot of
It was
money.
a lot.
Anyway, Keegan.
Yes. All right. So since this week, I don't know if we mentioned it in our intro,
Oh,
but
that's
since
right.
this week's show is called "It's How You Use It," and it's about all the very small things in the universe. Mackie talked about a very small bird that people eat. Roman talked about a very small byte
Yeah.
of information. I'm talking about a very small amount of light. So the smallest amount of light that you can have basically directly translates to the darkest thing in existence. And scientists at Rice University and Rensselaer Polytechnic Institute developed the world's darkest substance in 2008. And what it is it's basically a carpet of carbon nanotubes, which we're going to talk about in our main topic section. And it's like a loose carpet of these nanotubes. And basically what a carbon nanotube is it's a hollow tube made of carbon atoms, and it's arranged vertically, so in a tube. And because it's packed into this, it's sort of like a loose weave, there's a lot of gaps between these tubes. And so it's both the structure of the tube and the loose arrangement of them that increases the amount of surface available to absorb light. And so it basically just absorbs more light than anything else has ever absorbed. The previous record holder was a nickel phosphorus alloy, which contained light trapping dimples. So it's like a golf ball almost. And but the previous record holder actually reflects 4 times as much light as this new carbon carpet. So
It's not white, though. It's pretty dark.
yes.
All right.
Now, but the new carbon carpet absorbs 99.955% of light which strikes it, which means that only 0.045% is reflected.
All right, well.
And reflection is the light that we see, right? And, you may be asking yourself, like, why would they create something? Like, why would they go out and try to make the darkest thing? There's a lot of applications in solar cell industries and stuff like that, where it's all about absorbing light energy. And so that's a good application for that.
Cool.
Yeah.
Okay. Well, so I guess that's...
Questions?
No.
Okay.
I have although I have some answers for you later. All right.
Okay.
Yeah, I guess that's the end of that then. So I guess we'll take our first song break.
Yep. And we'll see you back for our topic of the day.
You're listening to Symposium on rightradio.ca.
Things to come
Welcome back to Symposium on riotradio.ca. It is now time for our topic of the day, the very small.
Thomas Newman is a genius.
All right, so the way that the topics we're going to mention is going from the very smallest to pretty large, actually.
Yeah.
So I guess you'll find out. So the first thing is the smallest thing that I can think of, which is the Planck length, which is actually, well, it has to be, it's a theoretical value due to the fact that there's nothing small enough to ever measure it. There's not a ruler this size, which is...
And it's the smallest thing that could ever be measured.
Yeah. It's 1.6 times 10 to the negative 35 meters. And
Which just means nothing.
No, okay. So
to like the human mind.
So that's really small. Let me try and put it in terms that we can maybe understand.
Yes.
So an electron is 175 quintillion times larger. Does that help you
How many
out?
zeros are in a quintillion?
That's 15 or something. Oh no, sorry, it's
Alright.
20. 100 quintillion is 20 zeros.
Oh my gosh.
So yeah, it's extremely small, and the reason why we even bother making up this really small number is because when theoretical physicists do their thing, most of the quantum physics and that kind of stuff happens on that level. So that's kind of the best way to get a
Yeah,
handle
I
on
heard
it.
that it was once you get below a Planck length is when quantum physics is like
Most notable,
active
yeah.
or whatever.
Yeah, things start to break down at that level. For instance, Pythagorean's theorem doesn't work that low level. So
Yeah,
for
that's
instance,
messed up.
Yeah.
so
That's
for
pretty
instance, if you have 3 points, that would be normally form a triangle. The distance between each point is 1.
Ah, what? What? And it's a right angle triangle?
If it's a right angle triangle.
Oh my gosh.
Yeah.
That's really weird.
Although talking about right angles at that level is also kind of odd.
Yeah.
The
Also, interestingly, about Planck lengths, you can't differentiate between things that are less than 1 Planck length away. How weird
exactly.
is
Yeah. No, it's sort of like it's hard to even talk
that?
about.
If something is less than 1 Planck length away, then it's in the exact same place as it is now.
Yeah, it's too small.
It's
really.
the smallest
It's
unit
too
in which
small.
we operate. But yeah, anyway, so slightly bigger than that.
Slightly bigger than that is quarks or our quarks, which is okay. So I'm not a physicist, and when I was looking into quarks, I got
You go on the
basic
Wikipedia regression.
Yeah, that kind of thing. So quarks are what constitute hadrons or hadrons, and the definition of a hadron is what quarks are composed of. So
This definition is useless.
yeah, I like this. So an example of a hadron would be a neutron or a proton, and so quarks come in 6 varieties: up, down, strange, charm, bottom, and top, which are amazing names for things or types of things. So a neutron would be 2 down and 1 up quark, while a proton is 2 up and 1 down quark.
Is an electron a hadron?
I don't think
No,
so.
it's not.
Okay.
Nope. Yeah, and hadrons are they are held together they're held together by the strong nuclear force
The quarks
are held together
by a strong nuclear.
in hadrons.
Interesting.
Yes, and that's all I really had for that. And then a boson, so we're getting into the Higgs boson, which is the slightly larger, is a hadron, and I think it's a baryon. I don't know. So there's like all these things. There's all these things that I had to look up.
Well,
so,
tell us what's important.
Yeah.
yeah. So a boson is a particle with no spin, electric charge, or color change. And the Higgs boson is extremely unstable, and it decays into other types of elementary particles almost immediately. That's why it's so hard to kind of...
Right. And if that name sounds familiar, it's because we recently just found the Higgs boson. We confirmed its existence with the Large Hadron Collider.
It hasn't been fully confirmed yet. It's like, that is probably it, and they're doing
Well,
research right now to
they
fully
found
confirm
they
it.
found the thing that they predicted, right?
Yeah, they found the thing they predicted. They're trying to figure out if it is in fact the Higgs boson.
Right.
This is all just cursory extra stuff. It's almost certain. The definition they set out for the Higgs boson was met with sigma 5 confidence. That means that they're 99.9999% sure.
Yeah.
And so right now it's just formalities, but they actually had the declaration and the presentation suggesting that they actually had found it already. So Mr. Higgs, or Dr. Higgs rather, the fellow, I forget his first name, the fellow who first proposed the particle actually was there. He's like 88 now, very
it was
old.
50 years ago when he proposed it.
Yeah, so he was there, and
How cool is that?
He shed a tear. I watched the presentation.
It's the I was right tier.
Yeah. So if you don't know, that they say Higgs boson, or rather the Higgs field is the thing that gives everything mass.
Yeah.
But the Higgs boson actually weighs 4 times more than an electron, which has mass. So how can that be? It's because it works as more of a packing material rather than something that something would have. So it's like something you have to wade through to be able to get places or to have mass. So the way that the amount that stops you is the amount of mass you have. The amount you interact with that Higgs field is the amount of mass you have.
That's pretty cool.
So messed up.
So
Yeah,
anyway, I wanted to talk about carbon.
Sure, I
Did
just
you
want
have
to
anything else?
mention one more thing about the Higgs boson. So while it has no foreseeable, right at this point in time, direct effects on new technological advancements, it means a whole bunch in theoretical physics.
It's part of the standard model, right?
Yeah,
it's like confirming the standard model.
How particles acquire mass, insight into cosmic inflation, and a bunch of other things that are like really important. So
They're gonna finish physics soon.
Yeah, that's what they always
That's
say.
it.
in
just
like
close the
20
tome. We're
in
done.
20 years it's like, oh, we're done physics.
That's what they always say.
I know.
But so anyway, carbon, better than your things. I'm sorry. I'm very proud of carbon after reading this. You know what? We're carbon-based life forms. Putting all of that aside, putting the fact that we're based on carbon and everything we do is necessary for our carbon to exist, just the technological aspects of it have so many far-reaching capabilities.
Thrill us, Mackie.
All right, so graphene and nanotubes basically are the new materials that have come up over the last 50 years or so. They've, nanotubes are the tubes you talked about earlier. They're basically sheets of carbon rolled up into tubes. And graphene is just hexagons of one layer thick carbon. So
Hexagons,
yeah.
as in like they'd be like honeycomb.
Exactly.
Okay.
Very, very, very honeycomb-like.
Okay.
So it's actually very, very similar to graphite, but it's just one sheet instead of the 3 that graphite has. So the graphene is very, very strong. It's so physically strong to have a 1 millimeter thick band of this graphene and all the force of an elephant on a pencil wouldn't break it.
Is this what dimension is it strong in? Like if I had like the sheet, would it be strong if I like pulled it this way, or would it be strong in like a compression sense?
Well, short answer both. Long answer mostly compression.
Okay.
For instance, if you can make ridiculously strong cables out of this. You can make cables as the thickness of a human hair that can hold up several cars, 13 cars if I'm not mistaken. It's unbelievably strong, but that's more of a nanotube thing. But yeah, because these are so tightly packed, such tightly packed atoms, and they interact so strongly with each other, they are able to create these untold strengths of materials, and it's definitely got to be a huge revolution in building and manufacturing. Once we're able to cheaply manufacture them, all the things I tell you now have the small caveat of these things are very hard to make. We can't make a lot of graphene. We can't make a lot of nanotubes very cheaply. So, and they're also nanotubes, not graphene so far, have been found to be slightly carcinogenic.
Oh, yeah. No.
We weren't sure for a while, but they are.
I wonder how.
How?
They're very easily, they're so small, they're able to pass right through your body, and they do quite a deal of damage that way.
Jeez.
That's creepy.
Yeah. Here's just a few uses, and I had to really cut down on a lot of the technical stuff. I stopped myself from writing more just so because we have time constraints on the show. But these are some of the greatest ones I found. So it's actually this graphene can actually be used as a transistor. So the basis of all of our computing technology is based on transistors, and these transistors can be smaller. They cancel quantum effects at a smaller level than our current transistors. Wow. And they operate better when they're hot.
That's useful.
So it's a matter of we'll cut down on the fact you have a fan on your computer to keep it cool. Obviously, you're still going to have to keep it at a reasonable level, but the fact that it warms up is
helps it.
It helps us be able to compute at more harsh conditions. Mm-hmm. You can also actually alter by adding boron to the mix of the graphene. It can actually become flexible, and it has stretchability to it. So you can make that other different fabrics out of that.
That's weird.
Yeah. It's actually can be used as an electrical oxidizer and reducer. So for your chemists and biologists out there, you know how important that is for all chemistry and biology, being able to do
Major
that
reactions.
in the lab. You can control that with like a flip of a switch now. It also has the ability to make OLEDs, so you can actually hook these up in the right way under the right conditions, and produce light with them.
I get what you mean. It's like there's nothing they can't do.
There's nothing they can't do.
That's just weird.
On top of that, they have piezoelectric effects. So that means
what?
piezoelectric. That means that they can turn electricity into movement, kinetic energy. So they can be used in things like speakers and mics as well.
Oh.
So just
science. We need
honestly,
a soundboard.
I'm just running through these because we don't have much time to talk about all these. But for instance, these piezoelectric effects can be used are already being used as robotic muscles because you can apply an effect and use very sleek, very low energy,
and they
muscles.
would look like muscles,
and
too.
they both look like muscles and very small and don't require a lot of energy either. They can actually be used as batteries.
This is graphene still?
This is the mixture of graphene and nanotubes.
Okay.
I'm interchanging them.
Okay.
Pretty much the same thing.
The batteries, you can actually use a graphene, or rather nanotubes, as a battery because their shape actually stores electrons like a jar of electrons. The graphene, though, if you use that in the same way, it can be used as a capacitor.
Yeah.
So you can build every part of a computer.
That's
storing
like
electrons would be like a capacitor.
Absolutely. And not to mention, these transistors actually are analog transistors. I know that sounds strange, but what they are is they can actually, they're more like a resistor in that sense. So you can use them as a straight up 1 to 0 transistor or a resistor. So you can basically make every electrical component out of this graphene.
This is starting to go over my head a little bit.
They have a ridiculous amount of distillation ability. So what you can do is actually things like a graphene sheet allows water to pass through. I know that sounds weird. It allows water to pass through it, but nothing else, not even helium, not even hydrogen, can pass through. It has to do with the geometry. It's very complicated. We don't have the time or the knowledge ourselves. Maybe next week with Rupinder on, we can talk about this. But this was a shock to the scientists. They were baffled legitimately this time. Huh. It allows you to get like scoops of helium out of water, and helium's a very valuable resource right now.
Yeah, that's true.
You can do things that you shouldn't be able to do with this. Just water goes through.
Yeah.
So you can distill anything with just a simple mechanical movement. You don't like that, Roman?
He's gonna sneeze.
Oh no.
Oh,
no.
okay.
Oh, boy. All right.
Let's move on.
I do
wait, one more thing.
No more thing.
One more thing. It
my gosh.
It can actually. It produces if electrons hit it, it produces electricity. It's a solar panel too.
What the hell, man?
All right, going on.
You want to do the genome?
So we're not doing foglets? They're gonna skip foglets?
Well,
we're
we
kind of
can-
pressed for time.
Yeah. Let's keep going. We'll skip Foglet, sadly. So yeah.
Okay. So
Google foglets.
slightly larger is the smallest genome, which goes to the bacteria Carcinella rudi.
So what's
Rudi?
get close to the
Carcinella
mic.
rudi.
What's a genome for those
All
who
right.
don't
So
know?
a genome is the genetic material that an organism has, the entirety of their genetic material, their DNA.
Gotcha.
So the human genome is whatever 6 billion base pairs long or whatever it is. It's
However long
huge.
it
It's
is.
massive. So this bacteria has 160,000 base pairs long, which is actually half the amount that scientists before its discovery thought was possible in.
Which is basically nothing.
They thought that an organism needed at least twice as many base pairs to be fully alive.
Remarkable.
Yeah, and it encodes 182 proteins, and in humans, we have genes that encode for about 35,000 peptides, which can be arranged into however many proteins you want them to be. So that's pretty crazy small.
Yeah. All right. Well, so yeah, you just want to touch pretty quick on the smallest mammal and star?
Right, and the smallest mammal goes to the Kitti's hog-nosed bat, or also known as the bumblebee bat, which is named for its obvious size. It is max length 3 centimeters long.
Aww.
And I think it's in like Indonesia or
That's
somewhere.
got to be like the size of your thumb.
Yeah, no, it's like really
Something
small.
like that.
There's pictures of people like holding it in their hands. It just fits.
Imagine
in, like,
having like just like a handful of these bats.
free.
That reminds me of a funny story about monkeys.
They live in like small caves where like there can be anywhere from 300 to 500 just in this like small-ish cave.
Ugh,
That
Yeah.
sounds
So
really
weird.
awesome.
They're actually like really.
I
cool
want a
looking.
pet.
Yeah, I want
But a
one.
leash.
All right, so you want to touch on the smallest star? Or?
It's
Keegan?
not me.
Not me.
Oh, nobody did that. Okay, well.
Oh wait, no, I did the small star. My bad. It's not arranged. Okay, so the small star is called OGLE-TR-122b.
Oh,
And
that's the best star name I've ever heard.
yes, it's
So elegant.
you can just tell how small it is. It's a red dwarf, obviously. That is only about 20% larger than Jupiter, but has about 100 times the mass. So yeah, it's really, really small, and it's like just large enough to be a star. Any smaller than that, it would be considered a brown dwarf, which is a star that is not massive enough to have the
Fusion.
nuclear fusion to
Right.
happen.
Yeah,
and so
yeah.
To be classified as
Yeah.
a star.
to be
Okay.
classified as an actual star.
Okay, and
So, yeah.
I'm just going to touch real quick on the magnetar, which is the biggest thing we've got on the thing, but it's actually very, very small. Like you mentioned, the smallest star was just a little bit bigger than Jupiter, but this magnetar is actually only it's a dead star, right? After a supernova, they can turn into a magnetar or a neutron star, which is a variety. This is a variety of, and it's only about 20 kilometers wide. So it's from here to from here to Pickering is how its diameter. So magnetars are just the bomb.
You could
It's-
like walk around.
you
that
could
thing.
walk that, yeah, for sure.
in
so
like
yeah.
a
could survive
day.
it.
So yeah, it's basically the special thing about a magnetar is it's spinning. So it's actually doing full revolutions 20 times per second. That puts out a huge amount of electromagnetic radiation, and it's basically a giant
Magnet?
magnet. Exactly, that's the word.
Magnetar?
I mean, like, yeah. So they were first detected in 1979, but we didn't know what they were until 1992. So for a while there, we were just like, what is this huge blast of magnetic or electromagnetic radiation and gamma radiation? So on occasion, these stars will put out some gamma radiation, which we'll talk about, and that's I've gotten all confused now. Anyway, the inside of it is, you can imagine these things are quite massive for even though they are small. They're actually about 5 times heavier than all of the, or I've gotten confused again. Sorry, no, a thimble of material
Okay.
from the core of this star weighs more than 5 times the number of humans that exist today.
That's an odd way to put it.
Is it? Is that a weird way? I thought
I
that
think
was.
so.
I thought that was on the level. All right. Yeah, but basically.
So what, like 35 billion humans type thing?
Exactly.
The mass of 35 billion humans is
Exactly.
Within
equal
this
to the
symbol.
mass of-
It's far more massive than our star.
so it's very, very dense.
Very, very dense. And what happens is every now and then it becomes a little bit unstable, and a crack appears on its surface. and
That can't be good.
It's called a starquake, which just sounds awesome. And it's exactly what it sounds like. The surface cracks, and it lets out a blast of gamma radiation. Those blasts of gamma radiation is what we detected in 1979, 1998, and 2004. And it actually caused our entire magnetic field to compress. For our, and
From how far away?
Sorry, from how far away? That's the interesting part. It's actually from 50,000 light years away. And that's no joke, Roman.
That's not that far. I was expecting
That's
it to be
pretty far.
No, I know it's
50,000
far,
light years.
but it's not as far as like.
That means the thing did, like, the magnetar did that, and 50,000 years later.
No, yeah, I realize that. I would expect it to be a lot further away.
A
for some reason.
magnetar as near as 10 light years, if it had a starquake, we would be shred to pieces. Every atom would just dissociate from its neighbor, and we would just be destroyed.
So I'm guessing
We know-
magnetars are pretty lonely out there.
We know of a few magnetars, 20 actually, but we think they're far more common than what we found. They're about 1 in 10 supernovas become a magnetar.
Wow.
And they, they're dangerous, but we haven't found any near us, so we don't have to worry about it, at least for now.
So they're not bright or anything, are they?
No, there's
When you say the surface cracks, I'm like, okay, so now I'm thinking of like a solid.
Well, it is a solid. It's a solid because it's so dense. It's a neutron star. It is. It's just special in that it spins so fast.
Yeah.
That's pretty cool.
Yeah.
It's crazy.
Anyway, yeah, very, very interesting, very dangerous, and we don't have to worry about it yet.
So that's our
Alright,
our
yeah.
list of going up from the smallest to the slightly larger smallest.
Yeah, I think we're going to take a short music break. You're listening to Symposium on rightradio.ca.
I see a red door and I want it painted black. No colors anymore, I want them to turn black. I see the girls walk by dressed in their summer clothes. I have to turn my head until my darkness goes. I see a line of cars and they're all painted black, with flowers and my love both never to come back. I see people turn their heads and quickly look away, like a newborn baby, it just happens every day. I look inside myself and see my heart is black. I see my red door, I must have it painted black. Maybe then I'll fade away and not have to face the facts. It's not easy facing up when your whole world is black. No more will my green sea go turn a deeper blue. I could not foresee this thing happening to you. If I look hard enough into the setting sun, my love will laugh with me before the morning comes. I see a red door and I want it painted black. No colors anymore, I want them to turn black. I see the girls walk by dressed in their summer clothes. I have to turn my head until my darkness goes. I wanna see it painted, painted black, black as night, black as coal. I wanna see the
Welcome back. Now time for our quiz section. A little long.
All right, I'll take it over. So this week's quiz is called Bigger or Smaller. I'm basically going to name two objects or two things, and you have to tell me which one is bigger and which one's smaller. Really easy, right? And I encourage everyone at home to play along.
We still don't have buzzers. We're still working on it.
So how are you going to designate?
Uh,
Or why don't I just, well, I'll just poll. I'll just poll
Yeah,
you.
just poll.
All right.
Fine.
All right. So which is smaller, the largest bacterium or a dust mite?
it's got to be, which is smaller?
Yes,
Bacterium.
which is smaller?
The dust mite.
Dust mite?
Bacterium.
Bacterium. All right. The bacterium is 750 micrometers. The dust mite is 300 micrometers. So 1 point for Mackie. You keep track of your points.
Got it. All right.
Oh, wait. Is it smaller?
Yes.
Oh,
Smaller.
okay, my
Oh,
bad.
yeah.
Oh,
I thought it was bigger.
I thought
No,
it
because I was like, oh,
Okay,
okay.
go on.
Our
I'll
show
accept-
on the
I'll accept.
smallest thing.
no.
Which one's bigger?
No, yeah.
All right. The width of a human hair or the width of a standard sheet of paper?
Hair.
Okay.
I'm going to go with hair.
The width of a human hair is 100 micrometers. Width of a sheet of paper is 150.
Nice. Okay.
So 1 point for each of you.
Cool.
Keep
All
track
right.
of your own points. Okay. A thou or a twip?
The twip.
Do you guys know what those are?
No, I do not.
All right. A thou is 1/1000th of an inch,
Oh, yeah. Okay.
which
yeah.
is where it gets the thou.
Yeah.
And a twip is a typographical point. For example, 12-point font is 240 twips high.
Whoa. I don't know the twip still.
I'm going to go with the other one.
So
The
you're
thou.
saying the thou is smaller, and
Yeah.
you're saying the twip is smaller. The thou is 25.4 micrometers, and the twip is 17.6.
All right.
Tied. So, some slightly more familiar things. A chloroplast or a mitochondrion?
Oh,
Chloroplast.
God, yeah. I'm going to say it's got to be the mitochondria is smaller.
Chloroplast is 8 micrometers. Mitochondrion is 4 micrometers.
Yes.
wow.
All right. I knew plant cells were bigger, so. All right.
All right. A human X chromosome or a single E. coli bacterium?
E. coli.
Okay.
Oh, that's actually really interesting. I'm gonna have to say the E. coli.
The chromosome is 4 micrometers. The E. coli is 2 micrometers.
Nice.
Point for each of you.
Look how good
The
I am at this game.
Ultraviolet wavelength or the smallest virus?
Oh, it's got to be the virus.
Yeah, I'm going with virus too.
Both right. The ultraviolet wavelength is 60 nanometers, and the virus is 17. So, a carbon nanotubule or the X-ray wavelength?
Oh, I don't know enough about X-rays.
And of course, this is the carbon nanotubule width, not like the length, because they could be
Yeah.
as long as, you know.
All right, I'm
I'm
gonna
gonna
go.
go with X-ray.
I'm gonna go with the nanotube.
All right, the X-ray is smaller with 500 picometers, while a carbon nanotubule is
Super small.
1 nanometer.
And there's a whole range for X-rays too, which kind of
Yeah. So, a cesium atom or a glucose molecule?
ooh, I like that.
That is interesting.
What's
and
cesium like?
Cesium's big.
Yeah, it's like
Cesium is
114
big.
or something. No, less than that.
Glucose, though. I wish I knew the length of the bond.
Yeah, I know.
I could do the math right now. No. All right. No. I'm gonna say that the cesium atom is bigger. Wait. So the other one's smaller.
So the glucose molecule is smaller.
yeah.
I think that too.
The cesium atom is 500 picometers. The glucose molecule is 800 picometers.
Good.
Both wrong.
We're wrong. Oh crap.
Wow.
Oh man. All right. Well.
That's still pretty big.
I know it's close. So, a proton or a neutron?
I thought they were the same size.
Yeah, we were.
I guess they're not. You know what? I'm gonna have to say that the neutron's slightly larger. So the proton's
Yeah, I think
smaller.
the proton's smaller too.
It was a trick question. They are the same size.
Oh.
That is bull.
I know. I'll give it to Mackie because he mentioned that. They're
Okay,
both
good.
1
What?
femtometer.
You just affirmed what I said.
I
I get that point.
I totally.
Fine, you can each have a point.
All right.
Um,
We know who won.
all right, the lowest temperature on Earth or the lowest temperature on Mars? Which is lower, smaller?
Wait. The lowest temperature on Earth or Mars?
Yep.
I'm going to have to say that this is a trick question, or it's a trick of a trick question. Oh, that's just
Bluff or a double bluff?
I can't just
Naturally found?
Yes,
Okay.
naturally found.
Dead air. I'm going to say it's got to be Mars because you're tricking me.
Yeah, it has to be Mars.
No, it's Earth. Earth is smaller. I'm switching now. He's not.
I'm
You're
gonna-
saying
I'm gonna
Earth,
stay.
and you're saying Mars.
It's gonna.
Earth is smaller.
Earth is a negative 89.2
Yeah.
Celsius,
Whoa.
and Mars is negative 143. So Mars is colder. Mars is smaller.
How could you think otherwise, Mackie?
We were just
we
talking,
have an atmosphere.
we were just talking about how Mars is warmer than we think,
Average temperature's minus 20.
Yeah.
Okay. No,
All right,
but you got to
All right,
think
let's move on.
like if we were to do an absolute value, the negatives won't matter and
Mackie, just take the loss.
All right, sure.
The lowest temperature on Mercury or the lowest temperature on Mars?
Mercury.
Which one's smaller? Now this are you
Mercury
tricking
is
me
smaller.
again. Why would you do this to me? Okay, I'll go with him because he got it right last time.
So you're both saying Mercury's
It's like minus 600
colder?
or something. That's not.
It's-
It's impossible. But it's like super cold.
It's minus 220.
All right,
So
cool.
you're both right. And the lowest temperature on Pluto or the lowest temperature on the moon?
Well, it's got to be the lowest temperature. On
This,
Pluto.
like, they gotta be the same.
Well,
It's like absolute zero on the
I
dark
guess
side.
neither
of
of
the
them
moon.
have atmospheres, right? But maybe because maybe like there's some radiant heat from Earth.
Yeah, I was just saying it has to
So
be.
it's got to be Pluto, if
yeah.
anything.
It's gonna be.
So you're saying Pluto's
It's gonna be
smaller.
absolute zero minus some more stuff. I think.
Yeah.
Both saying Pluto? You're both wrong.
How?
You
The
described.
lowest temperature on Pluto is, I'll say this in Kelvin because it's just easier, 33 Kelvin, which is negative 240 Celsius. While the lowest temperature on the moon is negative 247, which is 26 Kelvin. And this was in some crater on the moon. It
Of
was like
course
at
it was.
the where the sun has never shone.
All right.
Wow.
Yeah.
Anyway.
So, moving on to our riddle. Last week's question I asked, I am very small and I have 6 flavors. What am I and what are my flavors? My dad commented, and he said neutrinos, but he is so wrong. The
We
correct
also had
answer,
Smarties as a.
Yes, we also had Smarties. The correct answer is quarks, which we talked about earlier. They have 6 types, which are actually called flavors.
I tried and I stopped myself from saying it. I was like, no.
And these 6 flavors are up, down, strange, charm, top, and bottom. So we have a new riddle this week, which Mackie wrote and kind of makes sense.
Wait, what? I made a riddle? I don't remember
Yes.
this at all. Okay.
This medium-sized thing is attributed with suggesting the biggest thing in the world is actually quite small. So
Was
I'll
I
post.
sober?
I'm not sure. I'll post that on our Facebook page and stuff. So you can email your responses to symposium.uit@gmail.com. Post it on our Facebook page, which is if you search in Facebook for Symposium
On rightradio.ca.
on rightradio.ca, or you can tweet at symposium_RR with your answers, and we'll reveal it next week.
All right. So next week is same time, Friday from 1 to 2. And we'll have a special guest, Dr. Rupinder Brar, and the show name is Yo Mama. You've been listening to Symposium on rightradio.ca. Thanks a lot, guys.